Thanks for that. Yes, thanks to each and every one of you here that is able to make it. I understand that you probably have a long day from school. Am I right? What time do you come back home to be able to make it for this 1 hour webinar? Okay, so how are we going to proceed? I think I have a few familiar names over here. I think probably teach you before, right? It's some of the names seems very familiar to me. Okay, so we have Benjamin, Bethany, welcome, Damien, David, Hannah. How do I pronounce the name? Xian Li, am I right? If I pronounce your name wrongly, I'm sorry. So you could let me know, yeah. And we have Ting Xuan, Li Ping, Nicole, and RL. What is the actual name? Like, and Tethers, well, Tethers sounds like a superhero character. It makes me remind me of Thor. And we have Tricia, right? Oh, hi, Shane. Living is your parents, right? Yes. Some of you might be using your parents' Zoom account. Yeah. Okay, so I'm not sure how much you know about me, teacher Amando here. A few of you who have took part in our short-term courses, or if you are our existing regular students, you will probably have met me, or we have have been learning together for a while. Yeah, so teacher Amando here from BlueTree Secondary. I have been in the with BlueTree for a while. I quite enjoy it here because the people here are nice, and well, sometimes the students are pretty interesting people as well. Yeah, and so during my free time, yeah, I like to, I'm pretty much an indoor person, so I spend most of my days crammed at home getting suntan from the artificial light. And yeah, so I like to read. And basically I play games also. My favorite game right now is still Mobile Legends. I've been playing it since the end of last year. Yeah, so uh, I play with my students sometimes as well, and also sometimes my students will just text me with if they have any queries like regards to sudden school questions that they are facing some difficulties, and they find no alternatives of other ways to solve it themselves. So they actually get to me. Yeah, so I will help them from time to time. Yeah. So yes, in order for you not to feel like this is some kind of passive YouTube video, passive learning, I believe you too know, right? That it's not going to be something that you will absorb much. So to get the most out of the value of the lesson today, please do participate by thinking about questions to ask. Okay, you can always type it in the chat. You could also, as I attempt the questions, you could do it together with me at the same pace, or even if better, if you are faster than me, you could also just help me out with the answer, throwing in the answer from time to time. Okay, so remember, the key thing is to think about questions to ask. I can't read your mind, how I wish I had that superpower. And if I am able to get to your questions, then I'll be able to help you more, right? Yeah, so let me first begin by asking, right? How much do you understand about the topic of, do you know what we are doing today? We're going to cover congruence and similarity chapter, right? Have you already learned that in school? Just type in the chat, please. Let me know. All right, thanks for your message. Hey, Malcolm. Yes, glad to be able to see you in. I'm a little bit concerned because Malcolm is one of my students that I teach for the math program. We do have the holiday programs held from time to time in case that the full-time commitment, I mean, the regular weekly commitment might be a little bit too hard for you. So we do have short courses available as well. Yeah, so Malcolm actually attended that, and he got to me saying that he couldn't actually log in into the Google Classroom. Yeah, the Google link doesn't work, so I sent him the files individually. Yeah, a little bit concerned because I think a little bit more than 20 people sign up for the course today, lesson today, but I mean, thank God we still have at least about three-quarters of you. Yeah. So thanks for your response. Yeah. So since you all have learned congruence and similarity before, could you type in the chat again? Okay. Give me one sentence. What do you understand about this topic? Or rather, what is the difference between congruence and similarity in your own words? Right. So my question is, what do you think the difference is, right, between congruency, and similarity? You can put it in your own words in probably one sentence or so, or a small phrase. Same, huh? Okay. We have, yeah, we have one answer. Oh, I quite like her answers quite a lot. We have uh, Francis saying that, okay, congruence means same, and similar means one big and one small, right? And then Benjamin says that congruence is same size, shape, but oriented differently. It could be the same. Similarity is same shape, but not necessarily same size. Well done, Benjamin. And also, is it still Bethany? Okay, Bethany add on that the congruence is also shaped with similar size. Similarity has same shape, but different size. Okay, so yeah, it's good. You all roughly all get it, right? So congruence is exact same shape, exact same size, but the similar triangle, similar figures will have the same shape, but they will have different size, right? Like what Francis says, one big, one small. Thanks for your response, okay? Let me start with the first question. Now, how many of you here actually doesn't have the worksheet? You haven't got access to the worksheet in some way. This is the worksheet. This is how it looks like. All right, so I could send to you through the chat. Wait, is it possible to send through the chat? Hold on. Yeah, I think I can do that. Okay, so if it's still a little bit inconvenient for you to just read the digital copy, get ready foolscap paper, right? And of course your pen, pencil, and you can write it down on the foolscap. Yeah. So any notes that I've been saying, sometimes I might say things, but now I tend to be having some people tell me that my writing is a bit untidy. So if you feel that you couldn't see certain things, just let me know. I will try my best to write again nicely for you. Okay, so I will send you the file. Wait, I can't send file. I couldn't send it through here. Okay, so we will just go about the foolscap way, yeah, the traditional way. All right, and a total of 5 questions here. I try my best to explain as detailed as possible regarding some of the key things that certain students might forget from time to time, and certain things that you probably have learned before, but over the June holidays, COVID-19, we probably have too much fun. I do, all right, and you have also forgotten some of it. All right, yes. So, Francis, I think you have to send to the attendees as well. Never mind, just forward the message. Okay, so let me begin with the first question. So the first question is focused on congruent triangles, right? And regards to a picture kind of question, we all love pictures. Most of us are visual people. So seldom when we see pictures, sometimes students will tend to miss the reading the words carefully. Yeah, it is important, it's paramount to also read the words carefully, especially when you get to upper secondary. There is this thing called a question 10 in your paper 2, and it is a reality real life question in which that the question could be very long, like you're reading some kind of article, and if you do not go into the details, you could miss out some important information that prevents you from getting the question solved correctly. Okay, So some of the things that is not in the question, it's not shown in the picture, is the length, right? The CE 5.6, BG is 3.2. It is not displayed over there. And even if you try to label the numbers in the triangle, you will probably realize that, hey, actually I don't have if you label them inside, you still feel that it's the overlapping triangle seems to be a bit confusing, right? So the first thing you should do, and I highly strongly encourage you to do, is to always draw your own triangle in the exact same orientation. Like one of the students, I think Benjamin or someone said that sometimes that there is the figures could be in different orientation, being transformed in a reflection, rotation, and it's very difficult to imagine in your mind a few times that how does the position actually transfer from one to another, right? So we're going to just focus on one triangle. Just be comfortable with a certain triangle that you like. You can choose to copy the orientation of AEC, or you can choose to copy the orientation of BFD. Just choose one. So I'm going to choose BFD, all right? The current position that it has. All right, and then I'm going to copy my AEC in the exact same orientation. So I'm not going to do any rotation on it. And I'm not going to care about how is it that the AEC is able to transform until it becomes BFD. Because if you do that in your head, you probably have to think about, okay, do I need to do a rotation? Do I need to further on do another reflection? Ouch, I got the dislocation. So yes, you don't want to think about the transformation in your head because it's really students will argue with me from time to time. They will say, hey teacher, I don't think it's your A is here, your C cannot be there, because if you turn it this way, that way, the C cannot be above or below, that kind of argument. So if you feel that you have similar problems, don't try to imagine a transformation. Just draw one and copy the exact same way for the other. But how do you know where is the points to choose then if you do not imagine? You can, if the question already provide you with the triangles that are congruent. Now remember that the naming convention is, they actually name in the exact same order of what the corresponding points that is equal to each other. So if I go 1, 2, 3, sorry, I shouldn't go 1, 2, 3 because I named B this way. So imagine my B is the first point, and then I'm going to put number 1 over here. If I go an anti-clockwise motion about it, then my second point that I will cover is F, right? And my last one is going to be D, isn't it? So if I go in this order, 3, 2, 1, that means you go point B first and then F and then B. So in the sense, your AEC will also be in the same order of 3, 2, 1, which means that the point D is actually corresponding with A. So you're going to follow A in the right side bottom corner as well, right? So A is going to be the first point there. F is my second point, so it's going to be same as the E over on the left side. And finally, your C is going to be the last one on the top. So you don't have to imagine whether you need to do reflection or not, right? Just basically follow the order of the question. They should correspond to each other nicely based on the position. Okay, and now we're going to label the angles inside as well. So do not just, so you got to change your point of view. Sometimes you have to look at the original figure. Sometimes you got to look at the two triangles that you draw. It's just about a matter of shifting to the correct, a different point of view, I would say, okay, different parts from time to time. Sometimes you couldn't see the angle property, you have to just, it's all about thinking out of the box, yeah. So B 65 degrees provided, and I know that my angle C is going to be the same, right? But a lot of students just simply copy into the picture, but they fail to show it in their steps. So be very mindful of that, and also particularly check for the marks allocated for that question. So if you think about, okay, it's a 2-mark question, probably you will need like a method, right? One statement that has the main method mark and another one answer for your second answer mark, right? However, even if it's a 1-mark question, do not think that the 1 mark is just basically equals to an answer. Sometimes the 1 mark is basically for a combo. You do a combination of both a correct statement plus the answer itself. So it could be as stingy as it gets. Like if you get anything wrong, the statement wrong or the answer wrong, then it's a flat 0. Yeah. So be very mindful. The examiner always look out for reasons, ways to minus off marks. Yeah, which is why some students may be very strong in math, but they still struggle getting their A1s because they couldn't be go into that kind of detail. Yeah. So the moment you say that angle C is also 65 degrees, I'm going to write that in my statement. I'm going to plan a little bit because I know that part 2 is asking for angles, right? So which means most likely that I'm going to show that statement in my part 2 itself. So I'm going to label ECA, which is the same as the FBD. And also, I have come to this habit that I like to label the angles in a certain order. So if I go ECA, like left, top, right, and I will also label FBD. Okay, I mean, in actual fact, it doesn't really matter whether you write FBD or DBF, but because you want to have that, build up that good habit so that when we name similar triangles, congruent triangles, we don't get the order wrong. Yeah, when they ask you to name a pair of congruent or similar triangles, and if you get all these orders messed up, the again street teachers will not be accepting that because they say that your corresponding sites doesn't follow the order of what you write, right? As what I per se just now regarding the position. Okay, so that's 65. Okay, and then certain street teachers will also expect you to say, hey, how do you know it's the same? Okay, it's a very tedious topic because angles question typically need you to put in a reason for almost every step. So you probably got to write, oh, because I know that it's congruent triangles, right? Okay, and then the 33 degree, you've also got to put it down. It is angle A, right? It comes from here. So you see that even though I know that originally it faces there, I just know that it belongs to angle A. So immediately I will put it on here and I will also put it in on the angle D itself. So I will just also say the angle BDF is also 33 degrees, yes? All right, then we also put in the length that we haven't labeled earlier. BG is where is BG? Oh, BG is only a partial side. It's not a full side of a triangle. So how are you going to show that if you create your own triangles here? You're just going to break down the BF into two parts, right? Which is another G here. And then you just simply label this thing as 3.2 cm. Okay. And the 5.6 for CE, I'm also going to label it inside. And the moment I know that because congruence means exactly the same, which means that I will also label my BF as 5.6 cm, right? So the first thing, quite simply, if you already draw and label all of this stuff, you can see that the FG is just one part of the whole entire 5.6 cm. So to find FG, you will just use the whole, which is 5.6, to subtract the top part, right? You will get the bottom FG. So that will be 2.4 cm, and that's the answer. Okay, next one is on part 2. So we already labeled a lot of steps already regarding the 65 and the 33. So I believe it's quite easy if you observe back to the triangle BFD on the left, right? You can see that to find BFD, there is the last angle of the triangle. You don't even have to look back at the original figure, which has some weird overlapping that could cause understanding problems, right? Sometimes the figure could get so complicated that there may be too many lines drawn, and you might not be able to see where is that, where does the congruency even take place, right? So let's find BFD by using what? A total of 180, right? You subtract away the two known angles already, and you will get your answer, which is, do you get 82 degrees? But can I just end it like that? Is there something that I have forgotten, right? What's that? It is the angle properties, right? So we've got to explain to the examiner again, hey, where does this 180 come from? It doesn't come from the question, right? So we got to say this comes from what angle property again? It's called angle sum of triangle. Now, when you learn this one, probably the different schools, different teachers will tell you, no, it's sum of angles in a triangle. The grammar might be a little bit different, all over the place. For so long that you have these three keywords, angle, sum, and triangle. Okay, it should work. Yeah. I'm going to move on to question 2. I want to be as detailed as possible, but I don't want to hold back on dinner time as well. So later on, we will try and squeeze in some time for Q&A if you need to clarify some of these above questions, okay? So question 2, now we move on into similar triangle, but no matter similar or congruent, you always want to start off with what is the first step I said just now? draw the triangles in the exact same order, right? So just choose one that you're comfortable with. I think I'm more comfortable with the flat, the EGF, the big one. I'm not comfortable by drawing the slanted thing. So I'm just going to follow the orientation of EGH, right? And I'm not going to care about how this EFI is going to transform to become a similar orientation as EGH. I'm just going to copy EGH to a smaller scale, right? I'm not going to care how is it being turned around or what. And then I'm going to just follow the order. So EGH, this is my point number 1, 2, and 3, which means my 1, 2, 3 will be as follow. E first, right? And then I go anti-clockwise. My second point is here. And my last point F should be on the right side. Okay, and same thing as just now, we're going to also transfer all of this information from the original picture into the triangles that we constructed. Now, when I teach this tip, there will still be some students who, they say there's a saying, say, old habits die hard, right? And certain students just find it very resistant to follow exactly what I said because maybe they think they can visualize it properly. A few students tell me that they say, oh, I can do it, I can just imagine it out. But then the thing is, do you really want to take the risk in your exam just to save the extra? I mean, how much time do you actually take? This is not a Picasso drawing, right? You can just draw, and you can see that I draw it within several seconds. Okay, sure, Benjamin, you can restart a computer. The recording link will be placed inside the Google Classroom as well. Yeah, so you will be able to access the part that you missed later on. Yeah, ciao, see you later. Yeah, thanks for telling me. Yeah. Okay, so for you who are still here, what did I say? Label the numbers, right? So I have EI 34 cm. It comes on the right side, but I know that it's now on the left, right? And then my EH is made of both EI and the 20 at the bottom added together. So again, immediately when I do a calculation, I remind myself I got to write in the statement first, right? So some students calculate very nicely, like they try and see where is my method 1 going to be, where is my method 2 going to be, but how do you know for sure? I mean, in terms of the experience, right, in the exposure that it comes to the method, you're probably not sure which is the actual one that they hit. It's going to hit the method mark. So you always want to play it safe by presenting properly every single step. So long that the number is a new found number, you got to write it out, right? Just have the patience to do that. Personally, I'm also one of the lazy people. I don't like to do this, but I know I got no choice because that's how it works, right, in Singapore. Yeah. So 54 cm on the right side here. Any other things I haven't included? There is still the 15 cm, right? So I'm going to just break down again because EG is the entire thing, but the 15 cm only comes from the bottom part, FG. All right, and for similar triangle, oh, I didn't say this point just now. So what makes the congruence triangle the exact same shape and size? They are, if you go down into the specific, basically all angles are equal. All corresponding angles are equal. That means if you follow the correct position, and all sides are also equal, right? This is for congruence. However, for similar triangle, as what you all say, only same shape but different size. So one of them you still got to keep, right? Which one is that? Is it all angles equal or all sides equal? For similar triangle, it will be all angles the same. Okay, all angles are still the same. Okay, there is no difference in the angle. They're still equal, the corresponding angles, right? However, regards to the side, of course, they're not the same because one big, one small, right? But there's something about the side that is still equal. What's that? It is called what? The corresponding side ratio, okay? As in, if you compare the same corresponding side from small to big, the ratio will never change. That means every single side of the big triangle is going to be that number of times of the small triangle. It's going to be equal. So it's the ratio that is equal, whereas for the congruence triangles, everything else is equal, right? Size is equal, angles are equal. So take note of this difference, yeah? If you go really down into the specific. So if you want to solve for the length of EF, this is quite a challenge because you actually you cannot even create the first pair of sides ratio. What I mean by that is if you maybe look at the right side, EF is corresponding with EH, right? Right side comparing the right side. But you do not have EF, so how can you form that ratio, isn't it? And if you look at the left side, I seem to have some number there. There is a EI and a EG. But EI, yes, I know it's 34, but my EG is not a complete length. There is not given. I'm missing the EF, isn't it? How do you even solve to begin? Because there is no ratio to begin with. How to start off? You have to involve what thing? You have to involve an algebra, okay? Whenever there's too many unknowns that prevent you from starting in any way, you always have to relate it back to algebra. So you got to introduce an unknown. But I usually typically would introduce X for that, but I don't want to do that for this question because I already know the name of each of the side, right? It's just EI, FG, and so on. So I'm going to create the focus is basically to get to the correct side ratio, right? And what I mean by that is you probably don't want to use the bottom one because this IF and GH, there is a blank, just a big blank. How can you create anything from that? I'm going to start off by focusing on the right side because at least there is a number EH, right? And I like to create the ratio using a small over big, okay? Because what do you think is the reason? Because it will avoid needing to write an improper fraction, right? You can always have a proper fraction as a reference, and later on I think it's easier to manipulate what most of us are more comfortable with. So I'm going to just focus on the first corresponding side on the right side. Small is EF over the bigger corresponding right side is EH, right? And if you want to solve an equation that involves an unknown, you can't just have a single fraction. You must have a complete equation, meaning there must be a left side equals to right side. And this small over big is not counted, right? It's just for me to explain to you. The main thing that you are writing is EF over EH is equals to another pair of corresponding sides, which we are going to choose the left-hand side because, again, there are some numbers over there. It's much better than you choose FI and GH, which is just a total blank, isn't it? So we're going to write the original name of the lines first, right? The line segment. So EI over EG, right? Okay, then I'm going to go into the detail by substituting the numbers that we have. So we do not have EF, that's what we need to find, right? But we have EH, isn't it? We know that EH is 54. And same thing on the EI, the numerator here, we have it as 34. At the bottom here, EG, you do not want to let it remain as EG because otherwise you will have two different unknowns to deal with. And this becomes some kind of simultaneous equation. You get the idea, like you don't know, hey, how do you solve for EF when you don't know EG? You get the idea. So there must only be a presence of one unknown. So we do not want to use EG. We want to split this EG out into the what we have already labeled over here. We have EF plus the FG, right? Which means EF plus 15. So if you change it to this way of presentation, then you realize, hey, there is only one unknown, which is EF itself, right? And basically, when you deal with the corresponding sides to get to solve similar figures, you will realize that many times you will have fraction equals to fraction. An equation that has a fraction on the left equals to another fraction on the right, right? And to continue, what we need to do is just to do what? We typically learn this thing called the Criss-Cross Multiplication, right? In which there's some students, when they do this method, they sort of got very confused with the way you actually multiply. Like some actually when you go down diagonally downwards to multiply, and they're actually not very sure with the order on the left and right. I mean, it doesn't really matter in an equal sign, in an equation like that. But when it comes to inequality and then you use and then you do a method like that, it could cause your more than and less than to be wrong. That means you're supposed to put the answer on the left to have something on the left is more than the right side, but you somehow switch the order to make it a different story. So just be aware that the proper way to do it, if you follow the arrowhead, you are actually using the denominator to go diagonally upwards, right? Like an aeroplane taking off. So the EF plus 15 is actually multiplying to the EF on the left side. Okay, so if you write the steps, it should look like this. Make sure you put a bracket because you are using the whole denominator here to multiply by EF, right? And on the right side, the 54 will go over to multiply the 34. And also don't forget that if you have the times, if you do it mentally, the EF got to times into both, you got to distribute into both the EF and the 15 as well, right? What is 34 times 54? 1836, right? Am I right? Okay, and then you can see that, hey, there is a EF square that appears, right, in the question. So whenever you involve a square, this is known as quadratic equation, and then the steps to solve will be as follow. You want all the elements to be moved over, right, like Tai Chi, to the left side, so that you can create a big fact zero on one of the sides, right? So you don't want to have, terms on the left and right when you solve for quadratic. Sec 3 will be a different story when you learn a new thing. But for now, Sec 2, just take it as every time you see got x square quadratic equation, you want to move them all to one side to create a zero, okay? Which means that I want to move my 1836 to the left side, right? And you should know by now, crossing over to the opposite side of the equal sign is going to reverse the sign itself, right? 1836 positive turns negative. Okay, and it comes to this moment, I'm not sure how much teacher has shared with you regarding solving quadratic. There are a few ways to do what is the next step, by the way? You have to do what? You have to factorize, right? And if you factorize with three terms, typically you will do either the cross method, something like that, right? And some of the schools will teach you they call it the Indian way, because the first person will make it popular. I think is a person from India on YouTube, okay, for the multiplication frame. So doesn't matter which one you use, so long you're comfortable with. But also at the same time, I want to prepare you for your upper sec. And in upper secondary, especially if you take A-math, additional math, the teacher will expect you, some of the teachers will say, hey, you no longer want to do this because it's so slow. They want you to actually be able to get out the factorized form in the bracket already without doing any of these methods. Okay, but how do you do that? So I'm going to do a working here in the bracket itself, and just simply by drawing two sort of smiley face, right, that appears, like inverted rainbow thing. It looks like a smiley face here, right? So basically the working here is similar to when you do the cross method. So the first position here is basically where you split out the EF square into, right? EF square is EF times EF, there's no other way. So EF times EF. So the first factor of EF I put in the first bracket, and the second EF I'm going to put it in the second bracket, just like if you do it in the cross method, right? It's not much different. Okay, then you know that the second position is for the this number 1836, but this could be a problem because if you really try one by one, 1836 is such a big number that there's so many combinations of factors, right? It could be, I don't know, 2 times 918, 3 times 612 or something else. You have to list out a lot and keep on trying. So what is the shortcut? This. Okay, just use your calculator to solve for the answer first, and then you will straight away know roughly what is the factor to split up. Okay, so if you use this kind of model, Casio, the typical, I would say slightly older version, you just press mode 33, mode 33. If you have the other more, I think it's more high-tech kind of Casio calculator, then you probably have to press mode 32, if I'm not wrong. Right? If you do not know how to get that, just let me know. If you're using a sharp calculator, there is a different version for that. I think it could be mode 622. Basically, what you want to get to is after you press mode, you want to get to something that says equation, right? Which is in this case 3. And then you can see there's many different ones. And if your calculator basically say, is it exponent, exp, quad, you want to choose the one that's quad. Okay, quad is a short form for quadratic. In this case, they put it nicely in the kind of things that is available, right? You can see that in the mode number 3, it involves an x squared, and that's quadratic. So that's why for this calculator is mode 33. Okay, if you press it correctly, it should display this 3 main letters, our first 3 letters when we learn English, ABC, right? So the A actually stands for the coefficient of the x squared. In this case, we have EF squared as the unknown, right? So the coefficient of EF squared is going to be that A. And you can see in this question, there is no number for EF squared, which means that you have to put a 1, isn't it? Okay, and then the B is basically coefficient of the linear expression. Linear means the x without the power of 2. So in this case, we choose EF as the coefficient of EF as the B, right? So 15, positive 15. You press 15 and you press equal again. And then C will be the constant, the number that has no algebra attached to it, and that will be your 1836. And see the sign carefully is a negative 1836. So I've got to insert a negative sign as well, minus 1836, and press equal again. Okay, so if you press equal one more time, the solution is going to appear. So the x1 answer is basically the first answer, which says is 36, right? And you press equal again one more time, it should display the second answer, which is negative 51. So which means that your factors of 1836 actually split up into 36 as well as 51. Yeah. But then which one is negative? Do you actually follow the sign here? The answer is no. If you follow the sign here, you're going to get it wrong. So typically, if the answer is negative 51, in the bracket, you should have a reverse in sign. So you should have a positive 51 instead. And just now, the other answer was positive 36, right? So your term in here has to be the opposite, which is negative 36. Okay, and then it comes back to the line again, this smiley face. What does it do? You just basically multiply the two terms that are on that line. So 36, negative 36 times EF. And then you do 51 times EF is the two numbers at the corner, right? And you try to find the sum of these two values. So 51 EF minus 36 EF, does it give you a positive 15 EF? If the answer is a yes, then you should choose the correct terms. But if you can get something else that is not 15 EF, then you have to change your terms. That means you got to erase away 36 and 51 and choose some other number. But if you use a calculator for help, very likely that you're going to get the answer, right? So it basically is the same as when you do the cross method. After you do the cross multiply, you will be able to see that there is a 51 EF here, right? And maybe a negative 36 EF here, and then you find the sum of it, right? Which will give you 15 EF. Right, so this thing is best done in a pencil because the teacher will find it very weird. I got this extra line to left. Yeah. If you do not know how to use your calculator to get the answer, later on you can check with me. Okay, we could. It's very hard for me to show because I only have this kind of calculator. Perhaps we can find a YouTube video together. Yeah. All right, so after you factorize, you will basically split up the answers into two parts, right? In order for the answer to be zero. Now, again, another reminder, some students forget to make the right side zero. So they will have other kind of numbers such as 30. They might even put a 1836 and let it remain on the right. Then they split up the answer to say that, oh, it's either the first bracket factor is 1836 or the second factor is 1836. No, it doesn't work this way. The only time it will work is if you have a zero, because for the product to be zero, this is actually multiplying to each other, right? Like the first bracket term is multiplying to the answer in the second bracket, isn't it? For the answer to be zero, you either need to have 0 times something or something times 0. There's no other way, right? You can't insert non-zeros to times together to somehow become 0. So which is why only 0 works, yeah? And then you will split them up to say that each of these bracket could have an answer of 0. So EF plus 51 is equal to 0, right? And then you solve for EF by making EF the subject. So you throw the number to the other side. And you will have that. So once again, remind yourself that this is talking about length here, and there is no such thing as negative length, isn't it? So don't forget to reject the negative answer, which means that EF can only have one value, which is 36 itself. Okay, so put the units there in cm, isn't it? All right, so we'll proceed with part. Oh, this is still part 1, right? I got confused with the labeling. What do I label part 2 again? Right, so now we get an EF. Let's use that information to get to part 2. Part 2 wants the ratio of GH to FI, basically the two blanks that we don't have just now. But how can you solve when there is not a single number at the bottom? You have to use a certain known ratio. And now you can create a known corresponding pair of ratio because you have one more number, which is EF, right? If you throw the EF into the picture again, you will have a 36 here. And you can create the same 36 here as well. There's another EF over here. So again, if you notice, I don't really look at the original figure much. Only sometimes when you are unable to use these two pictures that you draw, go back to the original picture again. Most of the time, I think we are able to solve the question just by looking at what we draw, right? We should admire what we draw. Isn't it so beautiful? Well, okay, so you will just get to a known pair of ratio. You can use EF over EH on the right side, right? You can also use the corresponding pair on the left side. Doesn't really matter which one. I think the right side is easier, right? Just one flat number. 36 over 54. So if I write again small over big, you don't really need to write small over big, okay? Just writing this to remind you what am I doing. I'm using the corresponding pair on the small triangle on the right side as my numerator, which is 36, over the corresponding bigger triangle on the right side is 54. And I make it become simplest form. You can use a calculator to check that. You get 2/3. Okay, and what this 2/3 means is that every single side of the small triangle is going to be 2 units, representing 2 units, and the big triangle is going to be representing 3 units, no matter which corresponding side you are referring to. And that includes the one at the bottom as well. I don't know what's the number. There's no way to find in this question, but it's going to be 2 units at the bottom, and your GH is just going to be 3 units. Okay. So be careful of the instruction though. They want GH to FI, which means that my bigger triangle, which is the left-hand side one, should come first, which means you have to reverse the ratio to make it 3:2. Yeah, so 3:2 is the answer. Let me go on to question. Do I have time for all of them? If I don't have time, I might skip one question. I'll provide you with the answer. You can take a screenshot. You're all very technology savvy, right? I think even more than I do. I come from, if I compare to you, I'm probably like an ancient creature already. So for question 3 wise, how is it different from question 2? It looks like it's about the same, but what I want to focus on is the general shape that you need to observe to be able to spot similar triangles, right, in general. So you are going to face more and more of such questions in upper set, but sometimes they will actually move one level down and present it in your current exam questions as well. So what is the shape that I'm talking about? First one is called a pyramid shape, okay? And both of these shapes requires you to see parallel lines. If you don't see parallel lines, then you cannot say that they're similar, okay? So the second one is in the hourglass shape. Again, it involves parallel lines with the horizontal one. Sometimes it's not horizontal. Maybe the triangle is slanted. You push it to the left, it's slanted to the right, or lying down a bit, or do some kind of upside down dance. I don't know. So just in general, look out for these two shapes. They will confirm be some similar triangle there. Okay, pyramid and hourglass. What I just shared here is I don't know how your teachers teach, but I think most places, even if you do have tuition yourself, if you have other math tuition, I don't think most teachers will have or share this concept. Yeah, correct me if I'm wrong. Yeah, get back to me. So you spot these two shapes, and again, even though I think for this shape, pyramid shape is the easiest type of triangle because the orientation is exactly the same. There is no rotation involved. There is no reflection whatsoever. Right? You don't have to flip like a roti prata just to be able to figure out, is it face left, face right? It will just be as it is. So you can actually choose not to draw the triangles again. Yeah, but I want to keep up good habit because good habit will build up excellence, isn't it? There is a saying that says something like that. So I'm going to draw the small triangle and draw the big triangle. And PTQ, PSR, right? Same thing as what they say, 1, 2, 3, 1, 2, 3. Throw in the numbers 15, 9, 18 here. Oh, sorry, that's not 18. 18 is only the QR. So again, I need to put in the point Q here. And then I'll put in the 18 here. And then a 21 below. And at the same time, I also want to put in the point T. I probably don't want to draw the line because I don't want to get confused where is the big triangle. I just put a dot will do. So the PT is 15 and there is no given number for ST. So that's all that they give, right? And to solve for similar triangles regarding the length, it is always to go and look for a pair of corresponding sides to put them in a fraction, right? Fraction is easier as compared to a ratio, right? Because you can always do the Criss-Cross thing. So where is the beginning point? Where is the first corresponding pair of sides that you will use? It's easier than just now, right? This time around, you will have the bottom number, right? It's a 9 there. There is 21. It's a complete set of numbers given to you. You don't have to do any kind of what's that word? I don't have to introduce any algebra. Yeah. So you will just simply write it as, okay, I know that TQ over SR. In fact, the proper way that the exam style, the answer key will always tend to present is they will immediately write a second pair of fraction as an equation already. But if you're not used to it, it's okay to just write a few more extra steps. Okay, so what I mean by that is, okay, so I know that I'm going to start with TQ over SR, small over big, because I have the numbers. I'm going to link to the question in my second thing on the right hand side, which means it must involve what? TS, right? Because they're asking for TS. But I don't have the length of TS, but you know that TS is part of this left-hand side corresponding side, right? So I'm going to create the second pair based on the left-hand side, right? Or the small and the big, which means PT over PS. You get it? Left over left equals to bottom over bottom. Yeah. So I'm going to throw in the numbers in my next step. So they usually the answer key will write something like that, like a general equation before they substitute the number in. Okay. So 9 over 21. PT is 15. The only thing I don't have is PS. So you can leave it as PS. You can find PS first, or if I want to do a little bit faster in my answer, I want to get to the answer faster. I will split up my PS into PT plus TS. Right? It's made of two parts, isn't it? So I'm going to change it to 15 plus TS. I think I mispronounced just now, right? Yeah, so when you do that, then when you solve for the unknown TS, it's already the answer. You get the idea? So that's another advantage of that. And then how do you proceed from here? We always try and get rid of whatever that seems to be most irritating to us, right? And right now, the one that's most irritating is those two things at the bottom, right? So that will be a cross multiply to get rid of the denominator, okay? All right, when you manipulate it, make sure you distribute the 9 into both terms. Don't forget that. That means 9 times 15. Did I get it right? No. 90 plus 45. Okay, and now we have 9 times of TS as well. 15 times 21. What's the answer? 210 plus. Am I right? Let me clear the calculator. Yep, 315. All right, and I want to solve for TS. So the TS has to be the only subject found on the left side. So you're going to keep the 9 TS on the left, and you want to move all the like terms, the value to the other side. So you move this 135, becomes negative, right? So 9 TS is 180. And lastly, don't forget, I think by now you should be expert in this already, right? When it asks you to solve for TS, means TS cannot even have the number attached to it, right? So I don't know whether how many of you here will still face this problem of forgetting to reduce it down to the coefficient of 1. That means there shouldn't be any other number except for TS itself, right? So it's dividing by 9. And there you go. This is my answer for part 1, right? Okay, so with this extra number, usually the part 2 will seem easier to solve because you will have another number that you can put in the triangle, right? Which is a 20 over here. So next one is to find PQ. Okay, PQ is the part where I take back my words, it's not that easy right now. You have to involve the right-hand side because PQ is this thing on the right, right? Like we're talking about this. Okay, so that fraction, however, if you put it as small over big, it is still going to be the same as what we have just now, which is still going to be 9 over 21. This has no change. The ratio of the similar figures, the corresponding ratio is always the same, right? So we are just going to immediately put it as PQ over PR, small over big, is going to be the same as just now, the 9 over 21 that we obtained from here, remember? You can go ahead and make it simplest form also if you like, which is 3 over 7. And then once again, I do not want to continue like that because I will have two different unknowns. They're not the same. PQPR different, right? So I need to simplify it so that there is only one unknown that appears in the equation, and that is if you split up the PR into two parts, it is made of PQ plus 18, isn't it? Okay, then once again, what do? Crisscross, right? So 7 goes up to the left. PQ plus 18 goes to times 3 on the right. I will just do mental calculation here, okay? All right, and same as just now, you will gather all the PQs, the like terms to one side to the left. So you move the 3PQ over, it becomes minus. You end up with 4 PQ. And finally, you will divide that by 4, right? And there you go, your answer will be 13.5. Let me move on to the next one, okay? If you find that it's too fast and you are unable to catch up and you haven't copied finish or something, remember there is a recording link that will be put in your Google Classroom. For a few of you who cannot access Google Classroom, I can send to you the link separately. Yeah, just get back to me, or you can get you can send to the admin team at BlueTree Education. All right, the next one is question 4. I don't think I will spend much time on it. It is pretty similar. It's just on similar triangles anyway, right? And you can see that this is a pyramid, isn't it? Like a small pyramid, a larger one here, a right angle triangle pyramid. The only thing add on is that when you want to solve for PQ, if you keep on focusing on one type of concept, in this case, we keep on doing the corresponding side ratio, right? You probably won't be able to solve for PQ. Okay, so sometimes you got to switch your point of view. Remember, you have to learn to adapt to different, you know that there's so many topics, and a lot of times because you learn many different topics, they like to combine a few of these topics into a single question. So to solve for PQ, actually, you need to tune in to our next week free recording, which is a free webinar again, which is on Pythagoras theorem. So if you notice, it's a right angle triangle that involve PQ inside, and you already have 2 of the sides, right? So if you perform the Pythagoras theorem, you can get to PQ. You don't have to use the corresponding side ratio that we did just now. Okay, so anyway, the answer for this is, let me check. What did I save my answer just now? AB will be 7.2 cm. All right. And then your PQ, after applying the Pythagoras theorem correctly, you will get 21.9. This is rounded off to 3 significant figures. So another reminder here is that when you round off your answer, do put this approximately equals to sign and write the accuracy. Okay, so some teachers say, oh, you just write the approximately equals to can already. Some teachers will say, no, you have to write the bracket with the accuracy round off to. So it depends on your school. But once again, if you always do the best practice, you can never go wrong, which is just to write both, right? And another reminder here is that before your final answer, actually how you get a 21.9 is to square root, right? And whenever you square root most of the numbers which are not perfect square, you're going to get a shock when in the calculator. They will give you like, whoa, like a big chunk of decimal place, right? Also known as irrational number, and there is no way you can change irrational number into a fraction, isn't it? So you will just need to write a more accurate answer before that. So what I mean by that is like if you after you solve PQ, before you have this final answer of 21.9, right? This is just a A and B question, but there are those more heavier, huge questions that have A, B, C, D, E, F, G. You get what I mean? H, I, J, K. Then you are gonna have a problem when you do all those later parts because when you get to part D and then you still use this 3 specific answer, your answer could stray off further and further from what it's supposed to be. Meaning that maybe your part D answer is actually supposed to be, let's say, 31.5, right? But because you keep on using this rounded off answer to continue, maybe your answer could stray off to maybe 32.3. And then the teacher most likely will give, if you write your steps properly, they will give you this thing called error carry forward. That means you got a method mark, but you don't get the answer. But if you don't present your steps correctly, then oh God, then how are you going to do it? They will not check properly and then they will just mark you 0, 0, 0 for the next subsequent part, right? It's very risky to do that. So make sure you always have this habit of writing a more kiasu answer. Best approach is about 4 decimal place, 5 decimal place. You can even write the entire calculator value as well. No need to go to that extent. Maybe 4 decimal place is good enough. Okay, and you're going to use that more accurate answer to continue with your steps. Yeah. Alternatively, you can always leave it in the exact form, which is actually in the square root form, right? And the square root form can also be used to calculate. But sometimes this square root thing could get very complicated. If you are too particular about making the value all the time as the exact value, you could go up to a point where if you learn trigo, Pythagoras theorem combined together, you probably get something like, oh, 31 over tangent 50 degrees square minus this is a square plus b square square root. So maybe you have, there are some students who get to this extent. Don't need to torture yourself until this extent. Just get a 4 decimal place, 5 decimal place answer, and then you use that to continue. It should be accurate enough. Yeah. So that's your answer for question 4. Okay, you do work it out in your own free time. Get back to us, right? If you need any help, just drop a WhatsApp text. I will free up my time just to be able to answer a question. Don't worry about that. Okay, so I want to spend a little bit more time just to focus on the last one here, because this is basically a summary of congruence, similarity mixed together in the question. Have you read it? Okay, so I take it as you read it already. Yeah. So they say that ABC is an isosceles triangle. Do label these things inside. If they say AC equals to AB, label the stroke to indicate that they are the same, right? The ACB equals to 55. So far, I don't need to split up into two triangles yet, because in part A, I don't know what is the two triangles that are congruent, right? So how can you draw it out? So just leave it as it is in the current number. And there's one more number, 6 cm over here. All right, and there's one thing you got to remember. If you are see an isosceles triangle, and just nice in the line, a vertical line here in the middle, right? It's going to be in the exact middle if you see that this is a 90 degree. I say again, if you see an isosceles triangle, one line down here that creates a kind of 90 degree, this must be the perpendicular bisector. Do you remember what this word means? Perpendicular bisector is the word that is the line that is 90 degree cut exactly in the middle, which means that this is going to be another 6 cm. Okay, so the two triangles left and right are actually identical. That is your answer for part A. Yeah. If you find it very difficult sometimes to spot where is the congruent triangle or similar triangle, you just need to think about how many triangles are there in the figure. Just think about, okay, I have DBE, the smallest one on the left, right? This small thing here. I have ABF on the left side. I have ACF on the right side, and I have the biggest triangle, the total, which is ABC, the whole thing, right? So among these four triangles, which one is same shape, same size? Obviously, it has to be the ABF and ACF, right? But again, do not anyhow name them. Don't just, like play mahjong or rojak. Do you know how to play mahjong? The order has to be exactly corresponding to each other. So if let's say you start with point A, right? Point A, if you focus on ABF, if you go down to B, like this way, then it should correspond to point C, because it's like a mirror image. You go like away from the center, right? So if you say angle ABF, you have to name it as A first again, then C, and lastly F. Okay, basically if this is 1, 2, 3, then this is also 1, 2, 3. Now some students say, hey, what if my answer is not like that? My answer is like FAB, for example. Okay, then what is this going to be? Okay, then again you can see the order. If you go FAB, meaning 3, 1, 2, then you should also go 3, 1, and 2. Okay, so there's a lot of answers actually, right? It can be 3, 2, 1, 2, 1, 3, 2, 3, 1, so long that you have the correct corresponding order. Got it? Yeah, that is answer in A. So you can just choose one. Right, B is where there is it involves the similar triangle, right? It says that triangle ABC and EBD are similar. So once again, when you see that, you don't want to imagine it from the original figure. You want to draw out your own triangles, and again, in the exact same orientation. Just choose one that you're comfortable with. Let's say I'm comfortable with ABC. I will just draw ABC as it is. And I'm going to copy ABC and draw a small one. I don't care about how is this triangle going to do what kind of transformation. I know that the question say ABC and EBD is similar. So if I go 1, 2, 3 this way, my E is going to be my first point at the top. B and D will be as follows, right? So there's no need to argue. Do you need to like that? Like that? Doesn't matter. Okay. Yeah, so then I will throw in the numbers again. So I will have AC 16. It's an isosceles triangle. There's another 16 here. Then I also have BC, right? That's double of 12, double of 6, 6 times 2. I haven't got that number out yet in my statement, so I need to write it out. 12 cm. Okay, and then you're gonna bring it to the another information here. They say that BE is 1/3 of BC. So even though right now there is not a single number, right? That is not 6. BF is 6, but BE is not 6. Okay, see carefully. So I need to be able to find one more length, right, from the given information here. I know that BE is 1/3 of BC, so it's 1/3 of 12. I will get my second number, which is 4 cm here. Okay. And once you have that, then I believe it's easy enough, because if it's an isosceles triangle, the smaller similar triangle will also be isosceles triangle. So there will be another 4 cm here, isn't it? Right. So you just say that ED is also 4 cm. And again, for very strict schools, actually even length itself sometimes will require you to write a reason, right? So it's the length of isosceles triangle. All right, then I need to use that to help us get to dA. And again, dA is like a partial side. It's not a complete side of a triangle. So I need to split this BA into two parts, right? To create a dA at the top. And to solve for dA, you realize that there's something missing. What's that? You actually don't know the BD as well, right? You don't know BD, you also don't know dA. So you can't use the 16 to minus anything because you don't have any numbers there. So the first thing to get to is actually BD first. And what thing do you use to get to BD? Using the corresponding side ratio, right? I already have the 4 and 16. I can create that as my first pair of ratio. So again, a good habit to write is write down the one fraction, the known pair of corresponding sides first, which is EB over AB. And then I will put an equal sign, and my right hand side will typically be the new thing I want to find. So since I want to find BD, BD must be at the top, right? Numerator is the small, denominator is the big, right? Which means it's corresponding to the bottom number BC over here. Okay, so I will throw in a number next. I will have 4 over 16 equals to still BD, because I don't have that, right? Equals to 12. And then I can make a simplest form first. And I will do a cross multiply. I understand that there are some teachers who actually teach you using the unitary method. That means not urinary, unitary method, which means that using a units method to get to the answer. But I feel that when you involve this type of questions, right, when there is like unknowns, you probably will face more challenge, right? When you just write 3 units equals to that 1 unit. It's probably more difficult, right? So I will be very standardized with my steps. It's all just crisscross, right? So 12 times 1 on the left, 4 BD on the right, which means my BD is 12 divided by 4, which is 3. Okay, once I get to 3, don't forget that it's not final answer. My 16, I can now break down into 2 parts. I know that the bottom BD is also 3, right? I can insert in both places here. And then 16 is the whole thing. So 16 minus the bottom 3 is going to give you dA. And there you go. We have completed our revision. The revision, because I just now when I asked you, you all mentioned that you have learned congruence and similarity. This should be one of the topics in your term 2, right? All right, so I will save maybe another 5 minutes of the time. If you have any questions, I'll be here to answer them. Please feel free. Dot, dot, dot. Can you see the silent dot, dot, dot? Okay, so don't worry if you feel that the questions maybe could come later. We would love to reach out to you. So you do have our, if you know the webinar today, that means that you know the access to us, right? Okay. What is angle DEC? Oh, in this question, you won't be able to get the angle. Yeah, there's not a single. Oh wait, sorry, there is, right? So there is a 55. I'm so sorry. There's a 55 degree here, And if you throw the 55 in the triangle you draw, which means that there is going to be a 55 here as well, right? So which means angle D is also 55. Okay, and because this is an isosceles triangle, I mean, if you go back to the figure again, this will be 55 here. If you draw in the picture, you'll be 55 here. Sometimes it helps you in the understanding. You just need to take time to, it's like solving some kind of jigsaw puzzle, you see. So you label in your triangle, you also label in the question, right? So to get to DEC, you just need to use angle sum of triangle. The shortcut is actually called exterior angle by just using the 2 times 55, meaning that the angle on the outside here, outside the triangle, is actually equals to these two angles that are far away, right? And this property is called exterior angle. If you forget this angle property is also fine, because you don't actually need to have this knowledge to get to DEF. You just need to use 180 minus 55, you'll get this angle, right? And then you use 180 again to minus that answer, you will get back DEC or DEF. Okay, thanks for the question, Li Hui, right? Any other questions? All right, thanks for your time today. I really appreciate that you able to make it and join us despite the long day that you have from school. So if there's nothing for me, ciao, guys.